Hello viewers, welcome to my channel. Let's know how to derive and use distance, section and midpoint formula in the coordinate plane. First, distance formula. Let's derive and use the distance formula for the distance between 2 points A and B plotted in the coordinate plane. Let x1, y1 be the coordinates of A and x2, y2 be the coordinates of B. Then draw the perpendiculars AE and BD on x-axis and perpendicular AC on BD meeting at the point C. From the figure, we have AC equal to x2 minus x1 and BC equal to y2 minus y1. Now, using the Pythagoras theorem in the right triangle ABC, right angled at C, we have AB square equal to AC square plus BC square, that equal to whole square of x2 minus x1 plus whole square of y2 minus y1. This implies that AB equal to whole square root of the sum of whole square of x2 minus x1 and whole square of y2 minus y1. This is the distance formula. Let's consider an example to know how to use this formula. Find the distance between 2 points A with coordinates 2, minus 5 and B, minus 3, minus 2 in the coordinate plane. Using the distance formula, we have AB equal to whole square root of the sum of whole square of minus 3, minus 2 and whole square of minus 2 plus 5. That equal to whole square root of minus 5 square plus 3 square, that equal to whole square root of 25 plus 9, implies that AB equal to square root of 34 units. That's your answer. Section formula. Let's derive and use the section formula for the coordinates of a point P which internally divides a line segment joining 2 points say A and B in the ratio say m:n. Let x1, y1 be the coordinates of A, xy be the coordinates of P and x2, y2 be the coordinates of B. Then draw the perpendiculars AC, PD, BE on x-axis and AF on PD, PG on BE. From the figure, AF equal to x minus x1, PF equal to y minus y1, PG equal to x2 minus x and BG equal to y2 minus y. Since triangle PAF is similar to triangle BPG by AA Similarity Criterion, we have PA by BP equal to AF by PG, that equal to PF by BG, implies that M upon N equal to AF upon PG, that equal to PF upon BG. That implies that M upon N equal to x minus x1 upon x2 minus x equal to y minus y1 upon y2 minus y. On solving, we get x equal to mx2 plus nx1 upon m plus n and y equal to my2 plus ny1 upon m plus n. This is the section formula to find the coordinates xy of the point P that divides the line segment AB in the ratio m:n. Now let's consider an example to know how to use this formula. Find the coordinates xy of the point P that internally divides the line segment AB joining points A with coordinates 4, minus 3 and B with coordinates 8, 5 in the ratio 3:1. Given that m:n equal to 3:1, this means m equal to 3, n equal to 1. Here x1 equal to 4, y1 equal to minus 3, x2 equal to 8 and y2 equal to 5. Now using the section formula we have x equal to mx2 plus nx1 upon n plus n, that equal to 3 into 8 plus 1 into 4 upon 3 plus 1, that equal to 24 plus 4, that equal to 28 upon 4, that equal to 7, implies that x equal to 7. Similarly, y equal to my2 plus ny1 upon m plus n, that equal to 3 into 5 plus 1 into minus 3 upon 3 plus 1, that equal to 15 minus 3, that equal to 12 upon 4, that equal to 3, implies that y equal to 3. Hence P with coordinates 7, 3 is the required point. Midpoint formula. Let's derive and use the midpoint formula for the coordinates of the midpoint P of a line segment AB. Divides it in the ratio 1:1. Let xy be the coordinates of P, x1, y1 be the coordinates of A, and x2, y2 be the coordinates of B. Then draw the perpendiculars SC, PD, BE on x-axis and AF on PD and PG on BE. Since P is the midpoint of AB, the ratio m:n equal to 1:1 means m equal to 1, n equal to 1. This midpoint formula can be derived using the section formula. Using the section formula, the coordinates of this midpoint are given by x equal to mx2 plus nx1 upon m plus n and y equal to my2 plus ny1 upon m plus n. Since m is to n equal to 1:1, we have x equal to x1 plus x2 upon 2 and y equal to y1 plus y2 upon 2. This is the midpoint formula for the coordinates of the midpoint of a line segment. Let's consider an example to know how to use this formula. Find the coordinates xy of the midpoint P of a line segment AB with coordinates a minus 3, 4 and b 1, minus 2. Here m is to n equal to 1:1. Then using the midpoint formula, we have x equal to x1 plus x2 upon 2, that equal to minus 3 plus 1 upon 2. Here x1 equal to minus 3 and x2 equal to 1, that equal to minus 2 upon 2, that equal to minus 1, implies that x equal to minus 1. Similarly, y equal to y1 plus y2 upon 2, that equal to 4 plus minus 2 upon 2. Here y1 equal to 4 and y2 equal to minus 2, that equal to 2 upon 2 equal to 1, implies that y equal to 1. Hence the coordinates of the midpoint are minus 1, 1. I think you would have understood how to easily derive distance, section and midpoint formula in the coordinate plane. Please like and share this video. Also subscribe my channel and hence press the bell icon to get the latest notifications of my videos. Thanks for watching this video.